Hey, how's it going? This is Mr. Hernandez, and I'm here to kind of give you a hint for the paper box Desmos activity. And so I'm just gonna go ahead and get to it. The main thing is knowing that here the height of the box is x. So if we write 11 minus 2, that notice that's the common term, in each of these 11 minus 2, 11 minus 2. So when you're determining the length, you still use 11 minus 2, but then you multiply it by the height, which is, in this case, we could say x. In this case, if the height is 1, you multiply by 1. If the height is 1.5, multiply by 1.5, 2, and so on. So by just leaving a general term x, we could just replace the place where the height would go with an x. And this gives you the length. Now we could do the same exact thing with the next term, with the width, 8 minus 2 times the height. And if the height is x, well, we can just replace this term in the parentheses with an x. Of course, I would like to probably even write it out without the x's, but the volume, when you come up with this now, this is the key. It's kind of tricky, because we don't have each of those terms. This first term is the height. The next term is the length, or we could just replace it with all of this. This is the length still. And the last one is the width, which we couldn't replace with all this. So we have our height, length, and width. So if we write each of these values on the bottom with x, well, the length is, or the height is x times, this is 11 minus 2x times, this is 8.5 minus 2x, and that will give you the volume. And what we could do instead of the dots is we can write, well, let me just go one more step. I'm going to put all these terms together and close together, and I'm going to use parentheses instead of dots. So you can see I'm using 1, 2, 3 of these terms down here, and that is going to give us the volume. All right, so this is the general, this is what you want to put into this value right here. And then then when you plug this equation in into the next slide, you get this shape here. Now the point of this is, when you were looking at these dots before, you might have thought that it was some type of parabola. You might have thought that it was going to be something like this. And this is a good place to write notes. If so, go ahead and pause the video and write this here. But yeah, this is a parabola or a quadratic. You might have saw this as like a sad face, right? If you drew two eyes, that's a sad face. You could also maybe have an equation like this, y equals x squared, but because this is going down, this is upside down, you could put a negative here. You might even remember it in terms of y equals ax squared plus bx plus c. So this is just to kind of bring back maybe some memories here. You could have maybe something like that if you factor it. But these are just the different forms here. And we might as well label them. This is a standard form right here. This is factored form. So this is just to kind of, refresh your memory on maybe what you saw last year. But now we have something like this, right? If you put this x and if you put three of these terms here, x, 11 minus 2x, and let's see, and then 8.5 or 8.5 minus 2x. So this is not a parabola at all. If I kind of make this horizontal axis a little bit wider, I might have a better view of it. So that is a brand new function, okay? This is not it might look like a parabola or a quadratic if you looked at it, just right here. Just that view looks like a parabola, but here you have, a new function entirely. So this is our new function, and if you want to, if you want to put all this here in your notes, this is another good one. So there's a new function, and it is called a polynomial. That's what this is. And we are going to talk about a lot of the things that we've talked about with quadratics. Specifically, something that you might talk about are the x-intercepts. So that's something that we still discuss. We still hold as important with this polynomial here. So eventually we would end up identifying this, and this as x-intercepts or solutions or roots or zeros. So these are so x-intercepts, solutions, roots, and zeros. And so that would be the most important thing that you get from this video, with the graph, I mean. So you have two sets of notes. One is the parabola, is what you already knew, standard form versus factored form. And then the other thing is maybe if you want to graph this, like a rough graph of this in your notes, and then label the x-intercepts and call them solutions, roots, and zeros, because that's going to be a big deal. We're going to use these words interchangeably, so I want you to be comfortable just knowing that we're looking for the x-intercepts. Okay, that's it.